Hi guys, we're almost done with our first lesson here on Introduction to Exponential Equations. You'll notice here we have f of x is equal to 3 to the x. That should look familiar, right? And since I've already done this in the previous two videos, I'm just going to make this really quick and fill in these values here, okay? Let's assume that we've already gone through and filled out our t-table, okay? Because I've already done 3 to the x in the previous video, okay? We know that if we graph this, that we're going to get something that looks like this. It's going to go through 0, 1, 1, 3, 2, 9, and on the other side it goes 1/3, 1/9, 1/27, and we get that thing that looks like it's going to hit 0 but never quite touches it. And then it grows quickly once it gets past that 0, 1 point, right? Okay. Here's what we know. This is what I'm asking you to do in the homework, is recognize, first of all, is that a growth or decay problem? That one's obviously growth because it's getting bigger as we go to the right. But we have a couple of other vocab terms that I'd like to talk about because you're going to get asked about this on the EOC and because it's going to come into play in later chapters. That has to deal with domain and range and asymptotes, okay? Let's talk about the asymptote first because I've hinted at it a few times, and then we'll go back and do domain and range, okay? The asymptote, the definition of asymptote is a line that our graph approaches but doesn't touch. A line that our graph approaches but does not touch. Okay? And as I look at that then, and I look at this graph, I see that this thing is going to continue to grow. And I know that it looks like it's going pretty straightforward, like straight upward, but we know that if we zoomed out on our graph, it's going to continue to go to the right because I'm just going to put in another x value. What's an x4, or x when x is 5, or x is 10, or x is 100, or x is 1,000,000. I can put something in there and get out of it, right? But on the other side, we've mentioned a few times here, this line is going to keep getting smaller and closer and closer and closer and closer to 0, but it's never going to hit it because I can put in whatever I want to, okay? I can put in 3 to the negative 100th power, and you'll notice then, oh, I got the wrong graph here. Ready? 3 raised to the x power. Let's delete all the rest of that stuff, okay? Here's my growth function. Looks like what we've graphed, and if I go to the table, you'll notice that it keeps getting closer and closer to 0. In fact, it's going in scientific notation because those numbers are so small, but it never hits 0, okay? There's no value of x that you can put in here and get 0 out of it because you're multiplying 3 by itself a number of times. And so the asymptote then would be the line y equals 0. Y equals means it's a horizontal line. The horizontal line is at 0. In other words, what we're going to start doing is we're going to put a dotted line in our graph right here. It's going to be hard to see, right? But the line would be right here. And that imaginary line is the line that our graph approaches but never touches with the y value of 0. That's what an asymptote is. Okay? As far as domain and range goes, domain refers to x values. Range refers to y values. So as I look at this and I say, okay, are there any values here for the domain that are there any values of x that I cannot put in? And the answer is no. I can put whatever I want in for x and raise 3 to that power and it's going to be fine. And so we're going to say that the domain for all of these is going to be all real numbers. And that simply means that I can put in whatever I want to for x. Okay? Sometimes you might see it. I don't know what it's going to look like on the EOC, but you're going to see a funky looking R that has like a double bar here. That's a script R. It's just like a cursive kind of font, if you want to think about it that way, but it means the same thing, okay? All real numbers. But if we look at the range, and that's really what we're more interested in here, what are the values of y that I can get? And you'll notice that I can go as far as up and down. I can go up as high as I want to. You know, 3 raised to the 90th power is going to be a pretty darn big number. But I can't go lower than 0. In fact, I can't even hit 0. And so what we're going to say for the range is the y value has to be greater than 0. And that's what we're talking about when we talk about domain and range. What values can I put in for x? What values can I get out for y? This is the kind of stuff that we want to be able to do. So hopefully that makes sense. I got some more examples here, but I'm really not going to go into it for now. Your job is to go through in the homework and fill out something like this for every single one of the functions I give you. Do a t-table and make a plot. Once you have the plot, Domain will be all real numbers in every single case, but the range is going to vary based on what I give you here. Sometimes it'll go down to 0, but I might take that thing and I might start shifting it up and down, left and right. And then, how do I identify the asymptote? You'll notice that the range and the asymptote both have 0 in them. That's not a coincidence. That's going to be the norm. The asymptote is the line that we're approaching but can't touch. The range is going to say we have to stay above that value. Hopefully that makes sense. I'll be there to help you out with the homework as we go through the first couple of days of Introduction to Exponential Equations.